So in this video, I'm going to talk about all the practice problems from 2.6, and what you're going to see is all the problems that I'm going to go through, and I'm just going to go through them one by one, and I'm not going to offer a whole lot of explanation. I'm just going to go through what the problems are and how you go about solving them. So 9a gives us two functions. Gives us f of x, which is x plus 2, and it gives us g of x, which is x minus 2. And the first problem in 9a, it says to find f plus g of x. It says to find that. So what we're doing is we're finding a new function. Okay, so what that means is we're going to take and evaluate the first function. Not evaluate, we're going to find what the first function added to the second one is. So we're going to take the first one and add it to the second one. Using properties of algebra, I'm going to combine the two x's, and the plus 2 and the minus 2 cancel out. There's your answer. Your answer for 9a is just 2x. For 9b, it has the exact same two functions, but it's asking for f minus g of x. So it's asking us to take the functions and subtract them. So I'm going to take the first function and subtract the second one. Well, the x and the minus x cancel each other out, so we have 2 minus a negative 2. So all I'm left with is a positive 4, and my new function is just a constant 4. (9c) asks us for what f times g is. So I'm going to take f of x times g of x. So I'm going to take x plus 2 and times it by x minus 2, which is going to give me x squared minus 4 if I do all the multiplications, which would be x squared plus 2x minus 2x minus 4. These two cancel each other out. So here's my function when I evaluate them, or when I multiply them together. The last one asks us for whatever f divided by g of x is. So if we're dividing the two functions, we're taking f of x divided by g of x. Now, in the previous video, I had a fairly complicated one. So in class, I might talk about a little bit more complicated one, because this one looks just like this. And you can't cancel any of this out because of the plus and the minus. So this is the division of these two things. So this is the division. This can't be simplified. So the question is, for the second part, what is the domain? Well, the domain is all the x values you can use. And we have a function that has a denominator, and you can't have a denominator of 0. So you have to look at this and say, I don't want a denominator of 0, so x can't equal 2. Because if I plug 2 in, I'm getting a denominator of 0. So in terms of interval notation, we go from negative infinity to 2. We're not including 2. And then we're going from 2 all the way to positive infinity. Now I'm going to look at checkpoint 37. 37, it has three problems for us. First of all, it has two functions defined. And it asks us to find two or three things. F composed with G, which is the same thing as this. G composed with F, which is the same thing as this. And lastly, G composed with G, which looks like this. So I'm going to take G of x here and plug that in for x in this function. So what it looks like is this. So I took G of x and evaluated it at x in the original function f of x. Well, we know what G of x is equal to. It's equal to x minus 1. And if I square this, I get x squared minus 2x plus 1. And this is my new function when I compose G of x into f of x. Now I'm going to do the reverse. I'm going to take this function and compose it into G of x. So what this looks like is f of x, I replace that right there, minus 1. Now, f of x is equal to x squared, so I'm just going to replace that with just x squared minus 1. And there's my answer for this. Now the last one's a little weird because you're taking this whole thing and plugging the function in to itself. So I'm replacing x with g of x. So g of x goes in place of x here, minus 1. Well, g of x is this whole function. So instead of g of x here, I'm putting x minus 1 there. So it's x minus 1 minus 1. So that's going to be equal to x minus 2. And there's my function evaluated at itself as a function. So looking at 41, we have two functions. We have f of x equals the square root of x plus 4, and we have g of x equals x squared. The problem is asking us for letter A to find f composed with g, and B is asking us to find g composed with f. And then it says to find the domain of each function and each composite function. Well, if I compose g of f, or f of g of x, I'm going to do some work over here to figure out what that is equal to. So I'm going to replace x here with x squared, so it's going to be x squared plus 4. And this is my composition function. Okay? Now, there's nothing that I can cancel out here. Okay? Unlike the one that we did before when we did some compositions and we canceled them out, this is all that we have. Okay? So this is my composition for this one. And we're going to talk about the domain in just a second. Now for the other one, if we talk about the other one, if I take g composed with f, which is the same thing as this, that is equal to, well, if I take this one and plug it into x here, I get x plus 4 squared squared, which is equal to just x plus 4. Now, there's two parts to this. We have to find the domain of each one. Now, if I look at this one here, we're asking ourselves, what values of x can I plug in? Well, we can't have a square root of a negative number. And x squared is always going to be positive. And anytime you take a positive number and add 4, your answer is always going to be positive. So this square root will always be positive. So you are not going to run into any problems with this. So the domain is going to be all real numbers. It's all real numbers because you're not going to run into an issue with this because we didn't simplify anything. This is what it looks like. We didn't cancel anything out, and squaring a number is going to make everything positive. Now this one, we're going to run into an issue. The reason is you think, looking at this, I can just take any old number and add 4 to it. But the problem is that that's not what we did before. We have to take a square root of a number before we square it. Okay? And when you take the square root of x plus 4, we know that that's going to have to be something where this here, this expression, has to be non-negative. So that has to be greater than or equal to 0. If you plug in a negative 5 or a negative 6, this won't work. It would work here, but this is the actual function. We just simplified it, okay? So this has to be greater than or equal to negative 4. So the domain for this one has to be from negative 4 to a positive infinity. The last one I'm going to look at for this section, and then I'm going to take a second on the next one. If we have a function, it's asking us, based on this, this is the result of a composition function. We need to describe what functions would be the result of making this composition function. And really, there's a lot of different answers that you could have for this. It doesn't matter which one you pick, but you have to ask yourself, this is the result of taking a function and plugging it in for x, for f of x. So we have to look at what the outside function could have been for this to work. Well, the outer structure of this appears to be a square, so let's just say that this is x squared. That means that we have plugged something in for x instead of x squared. Well, what's there instead of x is this whole 2x plus 1. So if I plug this in for x, I get this expression squared. And this is the result. If I compose these two things, I get this function. Now, it's not the only answer, but this is the one that appears the most obvious, at least to me.